Okay, we got to take a slight detour here because we need to work with factorials. And you're like, well, how come we've got to work with factorials? I thought we're doing some probability with this unit. Aha, I'm glad you asked. Of course, we know when we're working with probability, we're looking at a ratio, right? That's the fancy name for fraction. And of course, we've got a numerator and a denominator. Those are the fancy words for the top and the bottom of the fraction. And we always want to be able to count the number of favorable outcomes, and we need to count the number of possible outcomes. And sometimes these numbers get a little bit tricky to count, or sometimes these numbers just get like really big. And so factorials will help us out a little bit. All right, so the factorial, oh, it looks like an exclamation point. So it looks like you're really yelling the number out. And so we always start with whatever number, and we multiply by the next smallest number. And we keep multiplying by the next smallest number until we get all the way down to 1. Right? And we only use whole numbers, so we're not going to use fractions, we're not going to use decimals, we're not going to use negative numbers. We only use whole numbers. Now, if that looks like a bunch of gobbledygook, perhaps if we do a couple of examples, you'll say, oh, I see what you're talking about. All right, so what if I wanted 4 factorial? Well, if I want 4 factorial, I got to do 4 times 3 times 2 times 1. And if I do that real quick, I should get, what, 24? So there's my answer. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. Boy, these start getting big in a hurry, right? That's 720. Like, ooh, maybe I better try some smaller ones because these things are going to get huge in a hurry. How about 3 factorial? 3 times 2 times 1. Okay, and that's just 6. 2 factorial. Yeah, you guessed it. 2 times 1, which is 2. Now, we got to do a couple of unusual ones. One of them, of course, is, well, what if I just have 1 factorial? Simple enough. The answer is just 1. Now, if I look back toward the top of this slide, I notice I'm supposed to be able to use whole numbers. Well, the number 0 is a whole number. So what on earth am I supposed to do if I encounter 0 factorial? Well, by definition, we claim it is just the number 1. Now, if you're trying to figure out why would we ever need to use this, make sure you come back next lesson and you'll see why we sometimes have to use 0 factorial. All right. Now, besides just being able to calculate a factorial, we will often see them as a fraction. So in this example, I've got 9 factorial as the numerator, 7 factorial as the denominator. So the top of the fraction is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Bottom of the fraction, 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, if I multiply that all out, I would have 362,880 over 5,040. I don't think I really want to multiply out numbers that big, nor do I think I want to try to simplify that fraction. So here's what we do instead. Right, if I got 9 factorial over 7 factorial, of course, it's still that same progression, right? It's still 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 on top. And then on the bottom, it's still 7 times 6 times 5 times 4 times 3 times 2 times 1. But I can cross cancel. I can the 7 with the 7, the 6 with the 6, the 5s, the 4s, the 3s, the 2s, and then even those 1s cancel out. So I'm left with just 9 times 8. Remember, if everything that's on the bottom cancels out, we don't even have a fraction anymore. And of course, 9 times 8 is 72. Let's try another one of these. How about 7 factorial over 4 factorial? Okay, again, the numerator, 7 times 6 times 5 times 4 times 3 times 2 times 1. The denominator, 4 times 3 times 2 times 1. We can cancel most of that out. We're left with just 7 times 6 times 5. Well, 6 times 5 is 30. So 7 times 3 is 21, but oops, it was 30, so stick a 0. There I go, 210. 41 factorial over 39 factorial. No, I'm not going to type this whole thing out, right? I start with 41 times 40 times 39 times 38 times, and then I go dot, 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 times 3 times 2 times 1. And then on the bottom, of course, I'm not going to write the whole thing out. I'll go, 39 times 38 times dot, 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 times 3 times 2 times 1. Right, so if I get some really large numbers, I'm not going to write the entire list. And I'll say, hey, look at that. From 39 down to 1, all that cancels. I just have 40 times 41. Right, because if I tried to figure out 41 factorial, that's a gigantic number. Same thing with 39 factorial. That'll also be a gigantic number. But I just need to know the answer to the question. I don't need to know what those gigantic numbers are. Right? Now, 41 times 40, that's still not exactly small, right? 1,640. But that's the answer. Now, you're probably thinking, wait a minute here, you were talking about probability, and we know with probability we're supposed to get like fractions. None of these answers look like fractions. Well, that's because we're not calculating any probabilities here. This skill will help us figure out how many are in the possible solutions or how many are the favorable solutions, right? Or the, I should say outcomes, right? The possible outcomes and the favorable outcomes. So we want whole numbers, right? Because I want to know how many different things could happen. Okay, so we got a couple really weird ones coming up. We're like, hey, there's 2 different factorials on the bottom of the fraction. Okay, we're going to see a few that look like this. Notice that 3 plus 7 adds up to 10. We'll explain that more on the next lesson, why that has to happen. Right? But on the numerator, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then in the denominator, well, 3 factorial is 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, a lot cancels out, right? That 7, 6, 5, 4, 3, 2, 1 from the numerator and denominator cancels out. So now I just have 10 times 9 times 8 over 3 times 2 times 1. And I could just try to multiply it out and then reduce. I like to cancel, though. I like to say, hey, you know what? 9 is really 3 times 3. And I can get a 3 to cancel. 8 is really 4 times 2. And I can get a 2 to cancel. Now, if the only thing left in the denominator is a 1, we can basically ignore it. Right? Dividing by 1 is not going to affect anything. So we just have 10 times 3 times 4, which is 120. So say, aha, there's 120 possible outcomes. Now again, today we're just working with the skill of how do we calculate that number. Next lesson we'll start to figure out, okay, where are these things coming from and how do they relate to probability. But today we're just practicing crunching out answers. So next example, again, I gotta start at 11, go all the way down to 1. 2 factorial will be 2 times 1. 9 factorial will be 9 down to 1. And again, look at what beautifully cancels out. Right, so I don't have to do some huge calculation. I've just got 11 times 10 over 2 times 1. And 10, of course, is 5 times 2. And, of course, the 2's cancel out. Leaves me just 11 times 5, which is 55. Right, so that's what we're practicing today. We're just going to practice finding the answer to factorials. So we'll have a nice little worksheet as we ride off into the sunset here. Bam, bam, bam. Come on, sunset, get in the picture so we can actually see the photo. And, ooh, very colorful, dark skies as we approach nighttime.